electric bacteria are getting energy in its purest form as electrons. Electric bacteria produce electrons from rocks and metals. At high voltages, these bacteria eat electrons. At lower voltages, they transfer electrons back to the electrode. When they get rid of electrons, they generate an electric current. These microbes produce hair-like structures outside their body. These hair-like structures act as electric wires which transfer electrons between cells and their environment. Tens of thousands of bacteria join to form an electric cable that can carry several centimeters. The first bacteria in the chain takes electrons and passes them on the next bacteria. This helps microbes further away to hook up to the electricity source. Scientists identify up to 8 types of bacteria that eat electricity. These bacteria are very different from each other. Scientists believe there is a whole part of undiscovered microbial world. All living cells are ultimately powered by electrons, and most obtain their electrons from food. But these bacteria can survive on nothing but pure electricity.
Many of the most important things in life we take for granted. And that is certainly so with light, because light has created life on Earth. Everything we do and everything we experience depends on light. Human evolution started with lighting, and if you take all evolution, if you compress it into 1 year, then even we started only at which we will touch upon. It's also interesting to see that all the energy we use started with light. So fossil fuels that are being discussed on their relevance originate from sunlight from the past. Whereas we want to move to fuels that are generated by the sunlight of today and of the future. In that sense, when you look at light in human evolution, we see of course that human evolution started accelerating when people invented fire. It gave them a way to prepare different foods, and it gave them a way to start moving around the planet and to evolve. From fire, we moved to modern artificial light. And it's not that much more than a century ago that we were for the first time able to light our environments where we live, work and leisure with artificial electrical light. If you look at human society, maybe to take a step back in history, it's only 200 years ago, in 1800, when human population crossed the 1 billion. Then light, let's say in comparison to science, it's a bit longer ago than that we have artificial light, and that the science of light originated, and that is also the reason all science evolves on magnetic waves that are used for so many applications today. And 100 years ago, you can say that Einstein looked a lot at light, and not only at his famous equation, where energy is the product of mass times the light speed in square, but also many other things that he did. And then light in many areas where we communicate, light fibers, communication, smartphones, you name it. And that is also something that makes light maybe something that we take for granted, but that is really so intrusive and so important to everything we do.
The importance of light in photosynthesis, to understand the nature and the characteristics of light, that have revolutionized nearly every field of science. An important stage of the evolution of the universe occurred around 300,000 years after the Big Bang, when the temperature was cool enough for neutral atoms to form. Before that time, there were too many charged particles to allow light to travel more than a very short distance. After atoms were formed, light could travel immense distances. In fact, we can receive today light in the form of microwaves that has been traveling for over 13 billion years. Perhaps of more importance to us was the formation of the Sun and the solar system, including our planet, about 4.5 billion years ago. Earth has been bathed with light from the Sun ever since. It is our most important source of energy. Sunlight warms us, causes weather patterns, allows plants to manufacture oxygen and our food from carbon dioxide and water, and it allows us to find our way around in the daytime. The use of sunlight in photosynthesis, to make oxygen and carbohydrates from carbon dioxide and water, is a process first established over 2 billion years ago by cyanobacteria. They made the large quantities of oxygen in the atmosphere which allowed oxygen-breathing life to evolve. Today plants use chlorophyll to achieve the same result, keeping the atmosphere breathable, and providing food energy for us and all other advanced life forms. Of course, mankind has found other sources of light over the course of history. Fire is obviously the earliest of these, from the campfires of our cave, where our ancestors lived. Electricity is the source of artificial light today, starting with the invention of the incandescent light and progressing via fluorescent lighting to modern LED lights, microscopes and telescopes. They allow us to study objects smaller than our naked eyes can see, and objects at large distances, or astronomical bodies at enormous distances. We can also send light from one place to another using optical fibers.